Hello students and welcome back to the video lecture series of software engineering. Today's topic is project matrix. I am your instructor Ms. Shruti Rawal. So first of all, let us study what are the basic terminologies that are related to matrix. Now matrix, when people say matrix, you may relate it with the maths matrix. No, this is not the maths matrix. The spelling is different, the meaning is different, right? So let us try to understand what is matrix in software engineering. But before learning what is matrix, the first word that you need to understand is measure. Now what do you mean by measure? Measure is basically providing you a quantitative indication of the extent, amount, dimension, capacity or size of any attribute of a product or process. So let's take an example. If you have code and if you are counting the lines of that code, that is line of code, then line of code's quantity is known as a measure, right? The next terminology is metric. Now what do you mean by metric? Metric is basically again a quantitative measure of the degree or limit to which a system, component or process obtain or possess a given attribute. Now this is a very heavy definition to understand. Now let us take an real life example and understand what is the difference between measure and matrix. For example, if you are giving the mid-sem examination, right? So you have individual measures. It means you have individual marks for every subject. You have got for example 50 marks out of 60 in software engineering, you have got 30 marks in Java, whatever, right? So individual marks are known as measure. But when you have an average of all the subject, right? So you have a formula for that average, and that average is nothing but that is a matrix. It means in this semester, how is your performance in your mid-sem examination, right? So that is a matrix. So it is basically indicating you that what sort of quality you are giving in this semester. And the last terminology that we need to understand is indicator. Now you know what is a measure, that is individual quantities, right? You know what is a matrix, that is you are applying formula on this individual quantities, that is a metric. And when you are combining more than one metric, right? So you have 2 or 3 formulas. For example, you have a formula for average in mid-sem examination. Also you are giving GTU's external examination, so you have your SPI for that semester. Also you are giving Viva in that examination. That Viva is also bifurcated into internal Vivas and external Vivas. So you have different formulas for internal Viva as well as external Viva. So in total for one semester you have 4 metrics, and if you are combining all those 4 metrics, the final estimation will be that how is your performance in this semester. That is known as an indicator. So indicator is nothing but it is combination of metrics that provides insight into the software process, project or the product itself, right? So these are the 3 examples or you can say the basic terminology for understanding the project matrix. Now let us move further in software matrix. So whenever you are talking about software metrics, the basic 2 categories in which the software metric is divided is direct metric and indirect metric. So if we can measure something directly and if there is a formula applied on that direct measure, the metric which is created is known as direct metrics. For example, if you have a line of code, right, that is immediately measurable, and if you have the number of persons who are working on that particular project. So there are 2 distinct direct measure, and if you are applying a formula on that particular measure, right, so you are achieving a metric, that sort of metric is known as direct metric. And if you have something which is not immediately measurable, for example, you cannot measure the functionality of a product, right? You cannot measure how reliable it is. So if you are measuring reliability and you are applying the formula on that particular measure, that is an indirect measure, the metric that you achieve is known as indirect metric. Okay. Now let us study the 3 distinct metric category. The first is product metrics. So what do you mean by product metrics? Product metric basically describes the characteristic of a product, right? For example, what is the size of the product, what is the complexity of the product, what are the different or distinguished design features you are going to implement in this particular product, what is the performance of the product, whether the product is having a higher performance, whether it is working fast, whether it is working slow, what is the quality level of the product in comparison with the similar product in the market, how reliable is your product, it means whether are there any bugs or errors after deployment or not, what are the different functionalities of these particular product in comparison again with the similar products in your market, right? So these are the different characteristic of the product which decides the product metrics. The next is process metrics. Basically, process metrics is used to improve the development process and maintenance activity of the software. So you know what is a process, right? Process is basically the combination of activity, action and task. And whenever we are applying the process metrics, these are the basic entities to be considered. The first one is effort required, right? So what are the number of people, for how much duration they are working, that is the effort required. The time to produce the product, the actual schedule or the time to produce the product, that is also one of the entity in process metrics. The number of defects found. Why is this very important? Because the more number of defects you are finding, you are resolving the defects, right? Basically, the number of defects found is something that is not a very good measure. There are two terms, error and defect. Error, it means whatever bugs you are finding in your product before the deployment to the customer, and defect is all the number of errors that the customer is finding, that is after deployment, whatever error or bug you are getting from the customer, that is defects, right? So in process, number of defect is very important. It should be as less as possible. The next is tools and technologies that you are using for developing the project. The next is quality, the overall quality of your process, whatever process model you are using, is it the apt process model or not? And the last is how efficient is your process, is it a quality process, is it efficient process, is it according to our thinking or not, right? The next or the last matrix is project matrix, and basically the project matrix describes the characteristic of the overall project execution, and these are the entities which are related to project matrix, wherein first entity is number of software developers, how many developers are working on this project. The next is the staffing patterns, right? So what is the pattern, what is the team structure you are using, what is the staffing pattern you are using, what is the process model that you are using, right? The next is cost, the basic budget that you have, and what is the actual cost that you are spending on this particular project. Are you in profit, are you in loss, right? The next is project schedule, very important metric entity, that are we following the schedule or not, are we on time or not. The next is quality, again this quality is dealing with the overall project quality. And the last is assessment status of ongoing project, that is basically the project tracking, that there may be some assumption, there may be some estimation that we have done, but are we actually following those estimation or not, the actual value and the estimated value, how much deviation is there in both this value. That assessment is also one of the major activity, or you can say entity in project metric, right? So these are also the different three categories of metrics. Now let us study the first direct metric, or you can say direct measure metric, that is size oriented metric. Now what do you mean by size oriented metric? Basically size oriented metric measures the size of the project, and by size we obviously mean that line of codes. Now if you want to count the line of code, the basic rule is you have to count all the lines, but you have to exclude the commenting and the blank lines, right? But you have to include the header, all the declaration, all the executable part, all the non-executable part, all the non-executable statement, actually not the non-executable part like comments and blank, that you have to exclude. Apart from comment and blank lines, all the lines you have to count, and the count is known as line of code, and that is the actual measure in size oriented matrix, right? But because there are thousands of line of code in every project, that is in every real life project, we are basically normalizing them by counting the line of codes in KLOC, like in thousands line of code, right? So we are not generally dealing with LOC, but in thousands line of code, that is KLOC. Now this is a basic table which is generated while you are developing any size oriented metric for a project. Now these are the size oriented measures, right? So you have three projects, alpha, beta and gamma, and these are the different measures to be considered for developing a formula for size oriented matrix. The first column is LOC, that is the actual line of code, right? The next is effort. Now effort is basically number of person into number of months they are working on a particular project, right? So that is a multiplication of that. The next is you can say that dollar, it means this is the money, right? So 168K, it is also in thousands. The next is PP doc, that is pages per documentation. So the overall documentation that you have prepared for alpha, beta and gamma project, what are the pages per documentation, 365 or 1050, etc., right? The next is errors and defects. So we have already told the difference between errors and defects, right? Errors are the bugs that you have found in your project before deploying the project to customer, and defects are the actual errors found by customer themselves after you have deployed. So it is not good if errors are less and defects are higher. So here you can see the number of defects is always lower than the number of errors. And the last is number of people, the total number of people working on a particular project. So this is basically the quantitative data, or you can say the individual measures of every attribute. Now if you want to develop the size oriented metric, because this is a measure and we know that we have to apply some sort of formula for developing a metric, for size oriented metric, these are the different formulas that you can apply, right? That is errors per KLOC, defects per KLOC, dollar per LOC, pages per documentation per KLOC, errors per person month, etc. So this is nothing but the individual metric, that is error per KLOC is one of the metric, defect per KLOC is another metric, dollar per LOC is another metric. Every metric indicates some sort of attribute, whether in a good way or in a bad way, that is decided based on the metric value, that is a numeric value in size oriented metric, right? So this was all about the direct metric, which is size oriented metric. Now let us go to the indirect metric, that is function oriented metric. Now basically whenever you are going for function oriented metric, we are going to follow a number of steps. We are going to find a value that is known as FP, function point, okay, because we are going to find function point metric. So let us study step by step how to find this FP. So basically what does function oriented metric do? It measures the functionality delivered by the application. It is not directly measurable. We have widely used this function point metric and we have also normalized it. Now let us study what are the advantages of this over size oriented metric. The first is it is programming language independent. It is not dependent on any programming language. The next is based on the data that are more likely to be known in the early stages of a project, right? Because size oriented matrix is highly dependent on LOC, right? So LOC, when we will get to know? We will get to know LOC when the coding is started, right? So function oriented matrix is using some of the data, or you can say all of the data, which is highly based on estimation, right? So that is an advantage over size oriented metric, that we can start to calculate function oriented metric way before you can start size oriented metric. Now what are the disadvantages of function oriented metric over size oriented metric? The first is computation is based on subjective data. Very important. Function oriented metric is an indirect metric. It does not use directly any measure. It uses lots of data, and based on that data you will get a number. But all the data that you are using for achieving that number in function oriented metric, every data is subjective, right? That is not directly measurable. So you can have a debate over whether the function oriented metric data or the value, is it correct or incorrect, right? The next is counts of all the information domain can be difficult to collect if you are not an experienced company. If you are not having experienced developers, then all the count initially in the early stages for the information domain that we are going to use in function oriented metric for calculating function point may be difficult to obtain, because that comes with experience. The estimation always comes with experience. That is a basic rule in software engineering. The next is it has no direct physical meaning. That we have already told, it is not a direct measure. The data is subjective. So you will have a metric which is just a number, which is a quantitative indication of the quality, right? Now let us study the step 1, that is FP calculation step 1. Whenever you want to calculate function point, you will have a system, right? So whatever your system is, the basic 5 data that you have to calculate, let us study. The first is external input, EI. So if you have a system, we know that there are number of input that will that the user will have in your system. For example, if you are developing a web application, right? So you have a web page in which the user will input many of his or her personal information, right? So that sort of input data, you have to count what are the different input data that user can input in your system. That is external input to your system. So user will basically input data in your system. That input is known as EI, external input. You have to count the number of inputs that user may be able to input. The next is external output. Now whenever user is entering the data, it is a possibility that data is manipulated in your system and there will be some sort of output which you are giving to the user. For example, let us take an example of attendance system. When the student is entering his or her enrollment number, that entering enrollment number is external input, and his attendance report, like for example the system is giving that your attendance for this semester is 85%. So that is a data which system is giving based on the input, that is known as an external output. You have to count how much external output, the number of outputs that system is giving to the user, right? The next is ELF, that is external logic files, right? Sorry, the next is EQ. EQ means external inquiries, basically the queries. For example, you may have seen the filters in the website, right? If you have a shopping website, you are having a filter for gender, you are having the filter for price. So whenever you are clicking on that checkbox, what is happening? Now there is a query that is being fired on the system, right? So there is an input involved in the query and there is an output involved with that query. So input and output combination based on a query, that is known as an external inquiry in your system. You have to count how much filtration, how much query, how much internal external combination is allowed in your system. The next is internal logic files. Internal logic files is all the database which is internal to your system which you are using, right? And the last is external logic file. External logic file are the data which you are using from another application. For example, many times you are asked that do you want to log in with Facebook, do you want to log in with Gmail, right? Or you want to create your own account. Now whenever you are creating your own account, it means the data is being inserted in the internal logic file, the internal database. But if you are not opting for that and if you are getting logged in from some another application, the data that is used is from another application, right? So it is a possibility that our system is accessing some another application's database, that is known as external logic file. You have to also count the number of external logic files. Okay, so these are the 5 data that you have to count for our information domain. Again, the first is external input, the next is external output, the third is internal logic file, the fourth is external inquiry, and the fifth is external logic file. So clear what is the step 1? After step 1, what will we have? We will have count related to each of these entity. Okay, now let us jump to step 2. In step 2, you have to calculate UFP. Now, what is UFP? It is unadjusted function point. For computing for computing UFP, this is a table that we have to follow. Here you can see that the measurement parameters we already have, that is number of external input, output, all the 5 entities that we have measured in the step 1. That count you have to write in the second column, right? So this is the data we have. Now this is the weighting factor which is common or which is fixed. You have to decide whether the external input that you have count, it comes under the category of simple, average or complex weighting factor. Once you decide whether it is simple, average and complex, all you have to do is multiply the count with the weighting factor and put it over this column, right? Let us do that thing. So for example, in my particular system, the count is 2 for external input, and I am deciding that the weighting factor for my external input is average, right? So the weighting factor is fixed. If I have external input weighting factor average, the number for which is related to it is 4. So now what I have to do, I have to multiply the weighting factor with the count, that is 2 into 4, that I will get 8, right? Similarly, you have to do for all the other data. For external output also you have the count, you have to decide the weighting factor, you have to multiply them, you will get the data over here. For the external inquiry, you have the count, you have to decide the weighting factor, you have to multiply them, you will get the count. Similarly, for external logic file and internal logic file also. Now, once you have these data in the last column, what you will have to do for counting the unadjusted function point, that is UFP, just sigma this. You have to just add all this value and that is your count total, right? So 8 plus 15 plus 16 plus 40 plus 35 gives me 114, and that is my unadjusted function point, that is UFP. So clear what is step number 2? Step number 1 was calculating the individual counts for the 5 entities. Step number 2 is calculating the UFP based on giving the weighting factors individual to every entity, multiplying them with the count and then giving the total count, right? Now let us jump to step number 3. Step number 3 is the actual FP calculation, is value adjustment factor, VAF. Now in the first 5 entities, we have just considered all the things that are related to functionality of my project, right? All the input, output, query, everything was related to the functional requirement. But there are certain things which are which comes under the categories of non-functional requirement, like how is the performance of my system, will the operation of my system be easy, will the installation of my system be easier, right? So these all are the non-functional characteristics which we have not taken into consideration while calculating UFP. So that was unadjusted function point. The unadjusted comes because we have only considered functional requirement, but we don't want all the metric to be based on functional requirement. As a result of this, we are adjusting the unadjusted function point while calculating value adjustment factor, that is VAF, and that is based on these 14 data attributes. You can see data communication, distributed data processing, performance, end user efficiency, installation ease, reliability. These all are the non-functional attributes which may be good in your system, which may be bad for your system. So you have to give a value, you have to give an individual number to all of these 14 characteristics based on the influence of that particular characteristic in your system. For example, if the installation is very difficult in your system, right, so it means that 5 is the number that you have to give, and if it is very easy, then you can give 0. So from 0 to 5 you have to give one numeric number to each of these 14 characteristics. Clear? So that is step number 3, because we want to adjust the values in our FP based on the non-functional attributes as well, and these are the general attributes that the software engineer scientists have discovered to be affected in every software engineering project, right? So you are giving a number from 0 to 5 according to the influence of every characteristic to your project, and then you are getting the sum of all these 14 characteristic individual numbers. So that will give you the total count, that is total degree of influence, TDI, right? Just you add all the 14 characteristic numbers, you will get the TDI. Now we are jumping to step number 4, and that is your calculation of FP, function point, using the actual formula. The formula of FP is equal to UFP into 0.65 plus 0.01 into TDI. Now here there are only two unknowns in the formula. You need to memorize this formula, there is no other way, right? So after memorizing you can get an idea there are only two variables, or you can say unknown. The first is UFP, that is unadjusted function point, that we have already calculated in step 2, and the next is TDI, that is total degree of influence, that we have already calculated in step 3, right? Substitute those values in this particular formula. What you will get? You will get the function point FP. FP is function point, but that is not itself a metric. If you want to develop a metric using the function point count, you have to merge it with some of the other measure. For example, after calculation of FP, you are easily calculating other metrics like FP upon person month, FP upon pages per documentation, right? So this is the formula for metric, FP upon something. FP itself is a count that you have to find, and that is a count which is known as a indirect metric, right? So in today's lecture we have studied two types of metric. The first one was direct metric, in which we have studied size oriented metrics, and the next one was indirect metric, in which we have studied FP calculation and function oriented metric. So this was all about today's lecture. Thank you.